Art without engineering is dreaming. Engineering without art is calculating. This was said by Stephen Robert. Swarm robotics is also such an artistic creation, which are based on observing the behavior of animals who work as a group to achieve a bigger task. It's not a new concept, and it's also highly interested in the field of robotics research. However, there are not true real-world applications since it required a large number of robots to prove the functionality, unlike other robotic applications. And also it's costly and take much time and effort to build a bulk of robots before starting the implementation. So the most common solution would be to use a virtual simulation environment or use less number of robots and assume it works for a large number of robots. But this leads to a more theoretical outcome rather than a practical implementation. So we need a better solution. What if we combine the physical experiments with the virtual simulation? Could we achieve the advantages of both these realities? Yes. We simply call this combination as the mixed reality. It is an emerging technology which realizes the solution between abstract design and the reality. And it links the real environment and virtual environment through augmented reality and augmented virtuality. Now imagine we want to model a swarm behavior and develop an algorithm. We only have 5 physical robots, but it needs at least 25 robots to prove the functionality of the algorithm. So by harnessing the mixed reality concept, we could use the available hardware robots and fill the rest with the software-defined virtual robots. But however, in swarm robotics, inter-robot communication is essential to interact with others. It would be easy if these robots are in the same reality, but here this involves both physical and virtual reality. And also we can see the physical environment, but we cannot see the virtual environment. So we also need to have a mechanism to visualize both these environments together. Therefore, our solution is a mixed reality simulator with virtual reality, augmented reality based visualization environment. So here, the mixed reality simulator will act as the middle layer between the physical and the virtual environment, while the visualizer visualizes the movements and the behavior of robots. Now let's have a look at this system. This system consists of 5 main components, which are physical robots, virtual robots, the localization system, visualizer, and the swarm simulator. Physical robots are general-purpose differential drive robots, which contain various physical sensors and support for inter-agent communication. The robot firmware was implemented to support swarm behavioral implementations. It interacts with various sensors and functionalities while communicating with the simulator and other components in near real time. Virtual robot instances were implemented as operating similar to physical robots with virtualizing the functionalities of the physical robots. Robot testbed has a vision-based tracking system. It uses image processing with the support of AR markers to track the movements of the physical robots and updates their coordinates to the simulator. The web-based 3D visualizer can be used to visualize the movements and the behavior of robots in both realities together. The key component of this system is the swarm simulator. The simulator server acts as a coordinator between the 4 previously mentioned components. It is designed based on the following modules and emulators. Swarm controller is the root controller of the simulator. The robot controller manages the robots. Sensor emulators help to emulate the inter-reality sensor behaviors. Communication emulators help to handle inter-reality communication. Scheduler service handler manages time-triggered events. The localization controller keeps updates of robot coordinates and movements. Environment controller helps to model different environments and obstacles. MQTT router handler handles the communication workflows. Let's see how to set up and execute a swarm behavioral experiment. First, download and set up with the necessary environmental configurations and then start the simulator. All the necessary details and information are provided here. To prepare the hardware robots, clone the firmware repository and set up the configurations. You can use provided design patterns, functions and implement the algorithm. To create virtual robot instances, clone the Java Swarm node repository and implement the behavior similar to physical robots by extending the virtual robot class. Afterward, set up the virtual robots with the coordinates and the heading directions on the Swarm Java class and initialize the instances as threads to execute them in parallel. To visualize the physical and the virtual robot instances together, you can choose between virtual or augmented reality visualization. The virtual reality visualization provides a 3D modeling of the environment, while the augmented reality visualizer provides you an immersive experience of the environment with augmented reality techniques. The unique AR markers on top of the physical robots map the coordinates by Localization System to the simulator. To make the mixed reality environment more realistic, you can add virtual obstacles to the simulation. They can be defined using the environment module of the simulator. You can combine primitive shapes and design complex environments like this. We tried out 2 experiments to prove the functionality. Experiment 1, Color Ripple. In this experiment, we assign a color to a particular robot. Then it communicates with nearby robots and passes the message, the color like a ripple. For visual identification of the communication, the color will be indicated by the robots themselves. Experiment 2. Discover an object. In this experiment, robots move randomly and try to discover a specific colored object. If one robot discovers the object, it passes the message to others and they stop searching and change their color accordingly. This is the same experiment done with 3D visualization of 10 robots along with one physical object and one virtual object. Now let us see the theory behind this. Mathematical model. We use many mathematical models in the simulator. This is one such model we used in the obstacle controller to measure the distance from the robot to a virtual obstacle. Augmented sensing. Here you can see how a robot senses a virtual obstacle and a physical obstacle. So while it takes the distance measurements to the physical obstacle through its distance sensor, it makes a remote function call to the simulator to get the distance to the virtual obstacle. And then by considering these 2 readings, the robot will act accordingly. Augmented communication. So if a robot wants to communicate to a nearby robot, it sends a request to the simulator and simulator make a interrupt call with the message to the robots within that transmission radius. Applications. The main objective of this research is to fill the gap between the swarm robotics research and the applications. And also the concepts like virtual environment for physical robots can be further developed and make scenarios like search and rescue, bomb disposal and planetary explorations, etc. And also we can replace the high cost sensors like LiDAR or radar with augmented or virtual sensors in pre-known environments like factories and warehouses. So to get this experience by yourselves, we invite you to visit our website and follow the open source libraries and design patterns we develop. Why through that you will be able to develop your own swarm behavioral experiment in mixed reality. Thank you.